Yeah, then let's get started. I'm very happy to welcome Nuria Oliver today to our distinguished lecture series of our ELLIS unit. And just a few words on Nuria before I leave her the stage to talk. So most importantly, and that's why it's a specific honor for us today, Nuria is the co-founder and director of the ELLIS network, and also its vice president at the moment. And at the same time, she also co-founded and is directing the ELLIS unit in Alicante, which we just talked about a bit already. A nice building at the seafront, which sounds quite nice. In parallel, she's also chief data scientist at Datapop Alliance. She's also advisor to the Vodafone Institute, and has originally studied telecommunications engineering and AI at MIT. Yeah, I hope this at least gives a brief summary of some of the important highlights of your CV. And with this, as I said, I would directly leave the floor open to you. And I can say we're very much looking forward to your talk. So.
Thank you, Andreas. Well, thank you very much. It's a pleasure to present. I'm sorry that I cannot be in person in Stuttgart, but I guess we can do it with technology. So in my talk today, I'm going to briefly present the ELLIS unit in Alicante because it's a very different unit from all the other units. And I will also share a couple of projects that we are working on at the intersection between, I guess, biases and AI. The ELLIS unit in Alicante is the first unit that was created in Spain and is a special unit because it's the only unit that has been created from scratch, a little bit like a scientific startup. It's the only unit that it is legally a nonprofit research foundation that actually has the name ELLIS Unit Alicante. So I don't think there is any other foundation in Europe that has that as the legal name. So I guess we are really embracing the vision of ELLIS to the core. And it's also very special because it has been created with a very specific purpose, which is doing research on ethical, responsible AI for social good. So everything we do is around those topics. We are also trying to implement different way of doing research in terms of the financial model. So we are a private foundation, but we receive public funding from the Valencian government that we complement with private funding from sponsors and collaborators. So we are really trying to see if we can have a sustainable financial model that is truly private public model. And we are also trying to do research in a way that is a lot more similar probably to the way research is done in a lot of the kind of like US technology labs. So very agile, very focused on fundamental questions, intellectually free, ideally, non-bureaucratic, competitive at an international level, very collaborative, and also, socially and economically relevant. We work on 3 large areas, and these areas are very large because the unit, as I said, has been created from scratch. And this means that the day that we created the unit, there was nothing and there was no one. So it's really like a startup. So one of the biggest objectives of the ELLIS unit in Alicante is to attract talent to the unit. So very different from all the other units that have been created in existing universities or research centers, and the members are professors from those universities or researchers from those research centers. ELLIS Alicante is just brand new. So we are now 8 people in total, but we were 0 people, just like a year ago. And we work on 3 areas. The first one is called artificial intelligence to understand us, and it's about the computational modeling of human behavior, both individual modeling and aggregate modeling. In both cases, always with the objective of having positive societal impact, what is called AI for social good. The second area is called artificial intelligence to interact with us, and it's about the development of intelligent interactive systems and the study of the interaction between humans and these AI systems. And probably the most related work in this area that we are doing and we're going to continue doing is the interaction between humans and large language models. And the third area is called artificial intelligence that we trust. And in this area, we have two very big branches. The first branch is about addressing the limitations of today's AI systems, such as algorithmic discrimination, algorithmic opacity, the lack of veracity, the subliminal manipulation of human behavior, the violation of privacy. But then on the other hand, we are also studying the societal impact of AI, specifically the impact of AI algorithms on social media. And we have a couple of projects that I'm not going to talk about today about the impact of the beauty filters that are so prevalent on social media platforms, and also the algorithmic censorship of art. Because as you might know, the content moderation in social platforms is done algorithmically, and there is a reality, which is these content moderation algorithms actually are censoring human art, particularly if it is human art that depicts any kind of nudity, and particularly female nudity. And this is a very impactful impact of AI, because of course, you know, algorithms are judging human creativity in a sense. We have a scientific advisory board, which is composed of many ELLIS fellows, but also other scientists from the US that are not ELLIS fellows. We have a lot of associate researchers that collaborate with us. And then we also have visiting scientists. And actually right now we have a visiting scientist from the US, is Kaylin Bolt, which is the winner of a Fulbright Schumann Innovation Award. And she's going to be with us for 6 months, studying all the work that we did during the pandemic. And we have we participate in the ELLIS PhD program. In fact, one of the objectives of the ELLIS unit in Alicante is that everyone has an ELLIS label. So you're either an ELLIS PhD program or an ELLIS PhD student, or an ELLIS fellow, or an ELLIS scholar, or an ELLIS postdoc. So all of our students are ELLIS PhD students. Aditya, Adrian, Gergel, Julian, and Piera are located in ELLIS Alicante as the primary location, and Ben and Kajetan will be coming to ELLIS Alicante for their secondary location. Our focus in the next couple of years is going to be around these projects. So we are going to continue working on how we can use AI for social good and contribute to the 17 Sustainable Development Goals. We are working on human-centric federated machine learning, on human cognitive biases and AI, which is one of the projects that I will present, on fair and explainable algorithms, and I will present another project on fairness in algorithmic fairness. And then we are also working, as I mentioned, on the social impact of AI, and we also do a lot of thought leadership and a lot of like media collaborations, a lot of talks to all sorts of audiences, including teenagers or like the general population. Last week, we had over 150 high school students that came to ELLIS Alicante to learn about AI. Tomorrow, I'm giving another talk to another few hundred high school students. So we do a lot of outreach because we are worried about the lack of interest in a lot of the teenagers into studying engineering or computer science. And of course, we are very worried about the lack of gender diversity in the field. We need to attract a lot more women to computer science. And to do that, we need to engage with the students, you know, even since primary school. The ELLIS Alicante unit was formally created in the summer of 2020. But of course, there was the pandemic, so it couldn't really start until October of 2021. However, during the entire pandemic, I worked a lot on the first area, the area of using data and AI for social good, specifically to help fight the pandemic. And even though I wasn't formally hired by the ELLIS unit because it hadn't started yet, I did all that work with the ELLIS sort of like unit's hat. And I had the opportunity to lead a team of over 20 scientists from the entire Valencian region of Spain. Actually, I didn't mention this. I don't know if you know where Alicante is located. It's in the southeast Mediterranean coast of Spain. in the Valencian region of Spain, and it's about 180 kilometers south of Valencia, if you have heard of Valencia, or around 500 kilometers south of Barcelona on the coast. So during the pandemic, because I had worked on the topic of data and AI for social good since 2008, I was very knowledgeable of all the state of the art on how we could use data analyzed with machine learning algorithms to support policymaking during the pandemic. And I felt that perhaps the policymakers were not aware of all this work, and perhaps we weren't going to be able to leverage all the evidence to be able to inform the decision making. So in March of 2020, I reached out to the president of the Valencian government in Spain. And I also reached out actually to the central government of Spain with the idea of creating a team of scientists working really closely with the policymakers to help them in their policymaking during the pandemic. This idea was very well received by the president of the Valencian government. And within a couple of days, really, they created this task force of over 20 scientists working with me on filling the gap that there is between where the data is and where the policymakers are. And we structured our work into 4 different very big areas. The first one was modeling human mobility, because obviously an infectious disease that is transmitted from human to human doesn't become a pandemic if people don't move. So modeling mobility was very, very important for any infectious disease, and especially also for coronavirus. So we were able to analyze aggregated, anonymized mobile data to understand the impact of the confinement measures and to also model the spread of SARS-CoV-2. The second area was building computational epidemiological models that would predict the number of COVID-19 cases under any possible scenario of confinement measures. We developed 3 different kinds of models that we run at the same time every day. And I think this is important when you are using machine learning in the real world. Of course, many times none of the models is perfect, but having a redundancy of approaches and models is very helpful to have more confidence on your results. So we were using 2 more traditional computational epidemiological models, a SAIR model and an agent-based model. And then we also developed a deep learning-based one using LSTMs. Actually, our models were very accurate, particularly the deep learning-based one. And this was one of the models that we presented to the X Prize Pandemic Response Challenge, which is a global competition to predict the number of COVID-19 cases in the entire planet. The third area was building predictive models, also using LSTMs, recurrent neural networks, to predict the hospital occupancy and the intensive care occupancy, both for non-COVID patients and COVID patients. And we also did another machine learning model to infer the prevalence of the disease, because I don't know if you remember, but at the beginning of the pandemic, in the first wave in 2020, we didn't have testing capacity. We didn't have enough PCR capacity. So we had no idea how many people were infected. And there was this question of, did we reach herd immunity? So we built a model to infer the prevalence of the disease way before they could do a seroprevalence study. And then last but not least, we deployed a citizen survey called the COVID-19 Impact Survey, which became really, really big with over 720,000 answers. And it was an incredible tool that helped us week after week to have a sense of the impact of the pandemic on people's lives. All this work is still very technical, and I think a key element for the success of our group was this layer here of results interpretation and aggregation, which was composed actually of a politician. We had the Director General for Public Policy. She was a member of our team, but she was a politician, and this is absolutely necessary. So she came to every meeting. We had meetings every day, sometimes multiple times a day. And she made a huge effort in understanding our work, translating our work into actionable insights, and also helping us prioritize questions to answer that were important to the government. We were actually the world winners of the X Prize Pandemic Response Challenge with our epidemiological models and our policy recommendation system. And we also won Best Paper Award in the Applied Data Science track at ECML PKDD, and we were all over the media, and we gave a lot of talks and so forth. We gave a lot because, as I mentioned earlier, for us in ELLIS Alicante, as important as doing high quality research is to do scientific outreach. We think it's very important to educate about AI to all sorts of audiences, both in terms of talks, but also in terms of media. So we collaborate weekly actually with the media, even more now because of the large language models, and we really try to help communicate accurate information and scientifically sound information about questions that society is wondering about. This is the very first part of my talk, just to give you an overview about ELLIS Alicante. You can interrupt me anytime if there are questions, because maybe it's more dynamic that way. It's kind of hard to give a talk so unilaterally without like having interactions. So if anyone has any questions about ELLIS Alicante or any comments, maybe you can ask me now before I move on to like the next topics, which are a couple of projects that we're doing on biases and AI. So I don't know if there's any questions or comments at this point. No.
Well, maybe a quick one from my side. I mean, I think you mentioned this before. So how big is the unit at the moment? So how many?
So we are 8 people.
8 people. Mm-hmm.
Yeah. So
Right.
we have a lot of room to grow still. So
Right.
we have postdoc positions or scientist positions at all levels.
Mm-hmm.
Our objective is that everyone would be an Ellis Fellow or an Ellis Scholar. So we want to be like 100% Ellis in terms of the members of the unit. Yeah.
Mm-hmm. I see. And this means they are also funded by the units, or do they kind of have positions elsewhere and they're just?
No. We have lots of funding. Yeah.
Right.
But what I mean in terms of the scientific excellence, it's important for us that, because to be an Ellis Fellow and to be an Ellis Scholar, you have to undergo this evaluation procedure from the Ellis Fellowship Committee. So it's sort of like a way to determine that you have a certain level of scientific excellence. So for us, this is important because our main one of our main funding, so we have public funding and we have private funding, and from the public funding is sort of like a guarantee that the individuals have the necessary level of excellence if they have already been evaluated by a committee, an external committee, to determine if they are Ellis Fellows or Ellis Scholars.
Mm-hmm.
Yeah.
Okay.
Of course, if someone is not an Ellis Fellow or an Ellis Scholar, but has the level of excellence, we also, of course, we're also considering those people, but it's just that that's kind of the level of scientific excellence that we would like to have, the equivalent to being Ellis Fellow or Ellis Scholar, or but that's why all the Ellis PhD students, they are all Ellis PhD students. They have been hired through the central selection process from
Right.
the Ellis. I don't know if there are any Ellis PhD students here connected, or I assume you're familiar with the Ellis PhD program?
Yeah, of course. Yeah, of
Okay,
course. Yeah.
cool.
Okay, cool. Thanks.
Yeah, so if anyone is graduating and wants to consider being a postdoc at ELLIS Alicante, or anyone, I don't know, wants to join as a scientist, definitely email me later. So I'm going to share now the work of two of our students, Aditya Gulati and Adrian, and both of them are working on two sides of, I guess, the same concept, which is the concept of biases. Aditya is working on how AI can help us humans be more aware of our own biases. And Adrian is working on how we can make sure that machine learning algorithms don't have biases and they have some kind of fairness guarantees. So the first part is about the intersection between cognitive biases and AI. So as you probably know, we humans have a lot of cognitive biases. A cognitive bias is basically a systematic deviation from what they consider rational behavior. Sometimes these cognitive biases are actually referred to as irrationality because they make us humans behave in a way that doesn't seem to make a lot of rational sense, because they cause some kind of perceptual distortion or some inaccurate judgments that make us select, the wrong decision, from a purely rational perspective. Probably some of the most famous authors in the area of human cognitive biases are Kahneman and Tversky. Of course, Kahneman is a Nobel Prize winner, and they did some very early work in the 70s on formalizing and identifying this concept of like human cognitive biases. Since then, there has been a lot of work, a lot of research, and there are some people claim that there are around 200 cognitive biases that impact our daily decision making. So they are really everywhere. And these cognitive biases, beyond us maybe on a daily basis, making us, pick the wrong whatever clothes or whatever, they do have a lot of societal impact, and they are leveraged in a lot of industries. More notoriously, of course, they are leveraged in marketing. Marketing, or the art of, like, I guess, human persuasion, is based largely on taking advantage of a lot of our cognitive biases. And these are some of the cognitive biases that are very well known and very much exploited in marketing. Something similar happens with addictions. Gambling, in fact, there is one cognitive bias called the gambler's fallacy, but any kind of addiction behavior or tools to promote addiction are also leveraging a lot of our cognitive biases. And this could be not only in the context of gambling, but also in the context of social media and the technology that we use. Beyond these well-established, I guess, areas, there is more recent work that shows how cognitive biases are also impacting political processes and politics. And perhaps more worrisome is the fact that there is evidence on how cognitive biases also impact judicial decisions and medical decisions. So it seems that it could be interesting area to investigate how AI algorithms could help us humans have a better understanding of all these biases. And then, of course, these biases happen in most of the apps that we use on a daily basis. They actually leverage these biases. But there is also this question. It's like, well, are they really bad? They exist, since we exist as a species. So they cannot be all that bad. There has to be a reason why we have all these cognitive biases. And in fact, many times these cognitive biases are referred to as heuristics, because in reality are shortcuts that make our decision making a lot more effective and fast. Of course, we cannot optimize a very complex function every time we need to make a decision, because by the time we make the decision, we've already been eaten by the lion or whatever. So there is a lot of reasons why we need to be very fast in our decision making. And these cognitive biases help us make these decisions in a very fast way. Of course, many times it might not be the best decision, but at least, we survive, as a species. So we are also interested in understanding that while mitigating these biases might be useful, there may be a space on recognizing that we have these biases, they are part of us, they have evolved with us, and maybe just investigating what should an AI system do, knowing that we are going to be biased and that we have all these different, heuristics in our decision making. So in this line of work, we understand that cognitive biases are a core element in our decision making. At the same time, we are increasingly relying on AI systems to make decisions. So what are the opportunities that emerge at the intersection between cognitive biases and AI? How do our cognitive bias impact the way we use AI systems? Should we develop AI systems that are aware of our cognitive biases? And what would be the optimal human plus AI systems that enable better, less biased decisions, being aware that we have, all this family of cognitive biases? So reflecting on all of these, we've drafted a research agenda that we just published a few months ago in the AAAI Fall Symposium. Actually, just a few months ago, where we discuss all of these, and we propose a taxonomy of how to structure cognitive biases from the perspective of AI systems. And I'm just going to share with you a little bit about this taxonomy. So, we are humans, and we, interact in an external world, and we perceive an external world. And we know from the literature that in our cognitive processes to interact and perceive and make decisions in this external world, we are biased. So we have biases when we interact with the world. We have biases when we make decisions about how to interpret what we are perceiving. We create mental models of the world, and we create memories from our experiences. And we also know that we have biases in all these different processes. So we have interpretation biases, we have value attribution biases, and we have recall biases. So we have structured all the cognitive biases into these 5 categories: presentation biases, interpretation, value attribution, recall biases, and decision biases. And recognizing that there is many of these biases, as I said, there is around 200 overall, we have done an exercise of identifying which ones are the biases that we believe are the most interesting and the most relevant to be considered in a situation where we have AI. This is when we only have biological beings, but then of course we humans interact with AI systems in the same way as we interact with the physical world. So we are interested in understanding how is this interaction, and if the interaction also has the same biases. We also can have an AI observing us humans and detecting, all these biases and making us more aware of them. And then we can also have the combination of humans plus AI to see how the human with the AI could potentially, be less biased or have a better understanding of the biases. So I just wanted to share with you the cognitive biases that we believe are the most relevant in the context of AI. In the first type of biases, which are the presentation biases, there are 4 that we believe are particularly interesting, which are the decoy effect, the framing effect, the anchoring effect, and the pseudo-certainty effect. And I'm just going to give you an example for one of these for each of the categories in the taxonomy. On the presentation biases, a very popular one that is used all the time is the framing effect. And we've seen this with the COVID vaccine, or for example, with this hand sanitizer. So you could have hand sanitizer A that says it kills 95% of the germs, and then you could have hand sanitizer B that says it does not kill 5% of the germs. And of course, these are identical statements. However, the vast majority of people are going to choose this one because killing 95% sounds more than not killing 5%. So this is an example of the framing effect. So if we think about our interaction with, say, a large language model, or a chatbot, we are interested in understanding how would humans be subject to this framing effect, or how vulnerable we are to the fact that the chatbot could be leveraging the framing effect to manipulate our behavior and to guide us into maybe making the wrong decisions. And we think this is something that should definitely be investigated. The second set of biases are the interpretation biases. And here, the ones that we think are the more interesting from an AI perspective are the conjunction fallacy, the base rate fallacy, the gambler's fallacy, and the hyperbolic discounting effect. And probably one of the most popular ones is the gambler's fallacy. So what the gambler's fallacy says, and this bias is called the gambler's fallacy because it has been notoriously observed and leveraged in gambling, and that's why it's called the gambler's fallacy. But it has been observed in other domains such as judicial sentences. So in fact, there are some studies like the one here included at the bottom of the page of how the judges that are granting asylum, that are making asylum decisions, are actually subject to this bias. And what does this bias say? So according to this bias, so imagine this judge has to make an asylum decision about these 3 individuals. And of course, the 3 individuals are uncorrelated with each other. These are 3 completely independent cases. So the judge looks at the first individual and decides to grant the individual asylum. Then it looks at the documentation for the second individual, and it also decides to grant the individual asylum. So then, due to the gambler's fallacy, the judge is a lot more likely not to grant asylum to the third individual than to grant it, even though this poor individual has nothing to do with the other 2. But it's simply because if the judge already granted 2 asylums, of course, the judge is thinking, oh my God, I'm not going to be granting asylum to everyone. I need to deny it to someone today. So unfortunately, just because of the presentation order, this person here has a lot more chances that it's going to be denied asylum. Of course, when we train machine learning algorithms on this data, there is a high probability that this algorithm is going to have the same biases that we train it with. So given that this bias is so prevalent, we're interested in studying how we can mitigate it and how can we actually detect it using machine learning algorithms. The third type of biases are called value attribution biases. And here we have the halo effect, the IKEA effect, the risk aversion bias, and the social desirability bias. And the one that we are studying, and this is actually an ongoing project, is the halo effect. So this halo effect is bias that makes us assign positive attributes to people that are competent in one domain, but not necessarily in other domains. For example, if I have to judge the financial advice from a doctor or from some homeless person on the street, I'm more likely to believe the financial advice of the doctor, even though this is a medical doctor and knows nothing about the finances, and maybe the person on the street actually knows more about it, but we are sort of like expanding the positive attributes of a person, to other domains that, from a rational perspective, the person doesn't know anything about or doesn't need to know anything about. We are particularly interested in one type of halo effect, which is called the attractiveness halo effect. And what this halo effect does is assign positive attributes to people that are perceived to be more beautiful. And actually, this halo effect has been found in many domains, including also judicial decisions. So if this judge has to make a decision about a certain individual, if the individual is attractive, it might get a more lenient sentence that is the individual is not very attractive. And this is, unfortunately, there is evidence that this happens. Of course, when we are interacting with humans, we apply this bias. Humans that are perceived to be more attractive, not only they are more likely to receive more lenient judicial sentences, they are also more likely to be perceived as more intelligent, more honest, less likely to be a criminal, more hireable, and generally better at everything. But of course, today we can replace the humans with, avatars or with chatbots or with AI systems. So when we interact with these AI systems, are we still subject to the attractiveness halo effect? We don't know because it hasn't really been studied. So this is one of the areas that we are studying. On the recall biases, the biases that are related to our memory, we have the false memory bias, the self-reference effect, the serial positioning effect, and the pick and rule. And one that we find particularly interesting is the pick and rule, particularly in this example of evidence of finding this bias when doing colonoscopies to people. So the procedure of a colonoscopy is actually quite painful and not very pleasant. And in this study, what they did was they did the regular procedure where, it took a certain duration and it had a certain amount of pain. And then they did a second option for the procedure where instead of just doing the regular procedure, they would prolong the procedure, leaving the probe in the colon, but not really causing as much pain as when the probe is being moved, because it would just be left there without really hurting the person. The procedure was longer, and the overall amount of pain in absolute terms was also larger because the procedure, the probe was inside the body for longer time. However, what the scientists found was that people preferred the longer procedure to the regular procedure. Why? Because this bias makes us judge an experience based on some specific points of the experience. And in this case, it was being judged based on the end of the experience. And because at the end of the procedure, the amount of pain was lower than with a regular procedure, even though it was longer and there was more pain overall, people actually prefer the longer procedure just because their memory of it at the end, it was less painful. So we can think of leveraging this bias when we have, for example, AI tutoring systems where, if we know that maybe learning is painful, maybe there is a way to organize the way we are teaching or the way we are trying to convey information in such a way that the end is more pleasant and less painful, in such a way that our memory of the experience, will be more positive. And last but not least, we have decision biases. And these are biases that impact our decision making. And we have the status quo bias, the shared information bias, the naive allocation bias, or the take the best heuristic. And the take the best heuristic is, I'm just going to give you an example, is sort of like bias that just makes us make decisions based on certain heuristics that we apply that might not have a lot of rational basis for them. For example, if I ask you, and of course, I think you're going to know the answer to this question, but which city has more people? And then the options are Ulm or Stuttgart. I don't know if someone wants to tell me which city has more people. Without cheating, you guys all live in Stuttgart, so no one is saying anything. All right. So most people, when they try to figure out, which city has more people, they would be like, well, have I heard of the city? And probably a lot of people have heard of Stuttgart than of Ulm. Is it a state capital? So we use a number of heuristics to make the decision, as opposed to maybe having the information really like a reliable information. We leverage all these different heuristics to guide us into making the decision. So given how much data training large deep neural networks models takes, an area that we think is interesting is seeing if we can leverage some of these heuristics to learn more efficient ways to build deep learning models that don't require, maybe huge amounts of data, and they can exploit some of these shortcuts that we are using in our own decision making. To wrap up on this area, our research directions that we have outlined and that we presented in this paper in AAAI are first in the area on the relationship between human and AI interaction. Do we have the same biases when we are interacting with AI systems as we do with humans? How should the AI systems incorporate, or maybe should they not incorporate the biases? Are they more human-like if they incorporate human biases like we are and we have them when we're interacting with other humans? And then how should we build AI systems that account for these biases? The second area is about embedding potentially cognitive biases in AI systems. So could we, as I mentioned in the last example, the heuristics example, could we somehow use these biases to build more efficient machine learning models? And the last area is about modeling computationally these cognitive biases. What are the best machine learning models to actually automatically identify and model all these different biases? As I mentioned, there's a lot of areas of application, but right now what we are running, we're going to launch, we're doing the pilot now, is a project on the attractiveness halo effect. And the first step of the project is this survey, which we call the beauty survey. And I will, if you are interested in participating, I can send to Andreas the information. We are going to be running one of the largest studies to date on the attractiveness halo effect. Because we are very interested in this particular bias and the relationship between this bias and generative models, and the fact that we can beautify ourselves with AI and maybe potentially make this attractiveness halo effect disappear in consequence. I don't know if anyone has any questions about this before I move on to the other type of biases that we are working on, which is algorithmic fairness.
At least I don't see any hands, but of course, if anybody has a question, now or later is also fine, of course.
I have a question. So for the beauty halo, you talked about generative models. So what do you exactly want to study there?
Yeah, so these two people are the same person, and one has been beautified. So we are interested in understanding if the same individual is, if indeed this person, the person on the right, is perceived to be more beautiful than the person on the left, then if this person is also, by virtue of the attractiveness halo effect, is also perceived as more intelligent, more trustworthy, less likely to be a criminal, more sociable, more hireable, etc., etc. And if this is the case, then we might be able to eliminate the attractiveness halo effect by applying beauty filters to our own faces and somehow democratizing beauty or equalizing beauty, because using AI tools, anyone can be almost equally beautiful, right? There is evidence, even though they tend to be small scale studies, but there is a fair amount of evidence on the attractiveness halo effect per se, but there isn't really much work on the impact that generative models or, beautification, algorithms that are obviously all based on AI, the impact that they have on the existence of the attractiveness halo effect, and how this can be possibly a tool for mitigating this effect if everyone is equally beautiful because of, applying these filters. Yeah.
So with the attractiveness halo effect, this is the case that if I perceive someone as more attractive, then I also perceive them as more successful, more intelligent, and a lot of other good positive attitudes.
Yes.
Then if we want to see how neural networks affect this, then if a neural network beautifies this person and this person's face becomes the person on the right, just by the fact that I ask people, is this person more beautiful than the person on the left? Isn't it the case then the direct consequence is that there will be attractiveness halo effect here?
Well, that's the theory, but because it hasn't been done empirically for the same individual, we don't know how much, we don't know in absolute terms how much these filters beautify people. Like if you're say if you're rated as a 5 and then with a beauty filter you're a 5.5, or are you a 6, or are you a 9? I mean, there is a lot of factors that play a role. Also race plays a role, gender plays a role, age plays a role, and we are actually we're doing the first study that takes into account all these other variables. Most of the studies were only done with one type of race, and not obviously with beauty filters, just with beautified individuals. There were some old studies that looked into makeup and the impact of makeup, but of course this is mostly for women. And there is a lot of very interesting questions. It depends on the gender of the rater. It depends on the race of the rater. So it's not as simple as it seems. And there is a need for a very comprehensive large-scale study to really shed light on all these variables. The research to date has been not very diverse in terms of the raters and also the subjects that are being rated. Yeah. If you are interested in participating, I can send you the link, even though I already told you a little bit about it. But of course, this is just the first step. We will have an amazing data set, and then we want to see how we can I guess build better AI tools, taking the knowledge from what we learned, in terms of like how susceptible we are to this attractiveness halo effect when you beautify people. Yeah.
One last question. So the images on the left, are you collecting them or are you using an image data set that is already out there?
No, for ethical reasons, we're only using publicly available image data sets. I don't think it is viable to do a large scale study. You need explicit consent from the individuals, and that is extremely complicated if you don't use publicly available data sets. Yeah, for face research. Yeah.
Thanks.
Senia, I see a hand. I don't know if.
I have a question actually. So there is in psychology there is a small research stream on attractiveness of women especially, and they show that too much attractiveness for women can have an opposite effect. So it's called beauty is the beast effect. And what's interesting is
that's another cognitive bias, by the way.
Yes, exactly. So that's interesting if this would also hold for AI beautifying, because for women it's a balance act basically to be attractive, but not too attractive, right? So,
exactly. We can actually design. We can design the beauty filter to beautify as much as we want, right? So that's a very interesting point as well, right? The level of beautification that would be the optimal level of beautification for an individual. Yeah. Go ahead, sorry.
No, my question was just, are you going to look at it as well? At this, like,
Yeah,
what's the right effect, or what's the right way to beautify?
yeah, so we are not, so the beauty filter is the same. We are not modifying. So another variable could be the amount of beautification, but that would explode the amount of participants that we need for this study. So we are using a beauty filter that is very common in social media, but so it's neither too, I mean, you can see it on the picture, it's neither too extreme nor too subtle. It's sort of like somewhat average, I guess, a beauty filter. We know about that effect. There is a lot of open questions that we don't know, because it also depends on your base level of attractiveness. So someone that is already an 8 and then it beautifies, then it becomes a 10. I don't know, maybe that's too much, but someone that is a 4 and then it becomes a 6, maybe that's an appropriate, level. So there is so many open questions that we don't know. And the research in this field has been very small scale to date, and in many cases using psychology students as the participants, like it happens in a lot of psychology research. And of course, psychology students are also not necessarily a representative sample of the overall population. So we're trying to do a pretty large scale diverse study, but we are not, we don't have as a condition the level of beautification. We are fixing that, and we are using as the level of beautification what we consider is sort of like average level of beautification of the popular beauty filters that are out there. But yeah, so I don't know if we will find strong evidence about that effect, the Beauty and the Beast effect, because I imagine that we will only find it for people that are already very attractive, and maybe with the beauty filter become too attractive. But I don't know. We'll see. Yeah.
Thank you.
I don't know, but we will look into the impact depending on the gender of the rater, the race of the rater, and the race of the person, and the gender of the person, and the age of the person. So it's quite diverse across all those different demographic variables. Yeah. All right. Any other questions? No. All right. So now I'm going to move on into algorithmic fairness. I'm looking at the watch. Is it okay to stay a little bit longer, or do I have to finish at 4 sharp?
Well, no, I think a few minutes are, of course, fine. And we've also done some discussion already, so I think it's okay.
All right. Because
yeah.
I mean, the other option is to skip this altogether, but I think it's interesting.
That would be a shame. No, I think it's okay.
Yeah. All right. So I've been talking a lot so far about the fact that we humans have a lot of biases. And one of the reasons why we are developing algorithms to help us make decisions is precisely because algorithms in theory don't have all these biases. Algorithms, don't have friends and don't have enemies and don't have hunger, and cold, and they're not tired, they don't get to have a bad day, they are not susceptible to corruption. So algorithms could be great, decision makers, especially, if they're trained with objective data, that represents the world. But of course, what we are finding is that algorithms also are not perfect, and they have a lot of biases. And there's been a lot of examples and a lot of cases. I don't want to spend any time here. I'm pretty sure you know about this, on a myriad of algorithms in all sorts of realms that have been shown to be biased and to be discriminating. In fact, as you probably know, the European Commission published in April of 2021 a draft of the European regulation of AI, what is called the AI Act, which it's trying to mitigate the negative consequences of using algorithms for supporting decision making, and particularly, among other things, to mitigating biases. So why are algorithms biases? So of course we have society, and society is biased. So if the data is collected as a reflection of that society, and then we are training machine learning algorithms on that data, so the data could be biased, so the algorithms could be biased, the algorithms could be badly designed, or they could be badly used. And at the end of the day, there are many reasons why, we could have different reasons to have bias in the algorithms. In the area of algorithmic fairness, one of the perhaps hardest questions is how do we actually define fairness? Because there is a lot of different definitions on fairness, both societal, from a societal perspective, and also from an algorithmic and mathematical perspective. So from a societal perspective, there are 4 key concepts to differentiate. So the concept of inequality, which means having unequal access to opportunities. So in this case, these 2 individuals, they have different heights. There is a fence. This poor person, doesn't see anything. This one has access, to the box that enables the person to see. Then we have the concept of equality, which would be giving the same tools to everyone. In this case, we will give the same box to everyone, but they don't have equal access, even though we're giving them the same tools, because this one is shorter than this one, so this one doesn't see and this one sees. To mitigate this, there is the concept of equity, which would be, well, we don't give the same tools to everyone. We give the necessary tools to everyone so they can actually have the same opportunity. They can actually have access, to the same things. In this case, they both can see. And then, of course, the aspiration of this field is to achieve justice, which would be a systematic change in society that would enable anyone to achieve, their potential and to sort of to achieve everything. And this is probably unrealistic, to happen in many domains, but is the aspiration of the field. So we have these different concepts, how do we actually express them mathematically? So in the literature of algorithmic fairness, there are many different metrics for fairness expressed mathematically. Generally speaking, there are these 2 different types. There is group fairness and there is individual fairness. So in group fairness, the objective is that groups are treated equally. So if we group by race or we group by gender, the entire group, will be treated similarly to the other group. In individual fairness, the focus are the individuals, and the idea is similar individuals should be treated similarly. There are a lot of different definitions for each of these types of fairness, group fairness or individual fairness. In our lab right now, the project that I'm going to present is a project on group fairness. The most common metrics for group fairness are demographic parity, equal opportunity, and equalized odds. This is basically defining these metrics. I don't know how familiar you are with the literature, but basically there are different ways of trying to express that groups should be treated similarly, and the groups are created based on what is called protected attributes. So it could be gender or race. Sometimes they are called sensitive attributes. It could be religion, and so forth. And the goal is that the algorithms treat the groups, equally. They have the same, for example, probability of being granted a credit or of being accepted in a university and so forth, independently on the group that you belong to, according to the sensitive attribute. I'll skip that. So in the literature of algorithmic fairness, there are 3 stages in the process of building machine learning algorithms where you can inject fairness and where you can model fairness computationally, which is the pre-processing stage, the in-processing stage, and the post-processing stage. So in the pre-processing stage, the objective is to make modifications on the data. So potential biases in the data are mitigated, and therefore the models that are built from that data are more fair. So there are a lot of different methods to try to remove biases from the data, from resampling and reweighting to data selection, data evaluation, to learning, fair representations. Some of the advantages of these pre-processing methods is that in many cases, they are model agnostic, because you're looking at the data itself. You're not so you could apply them to any other model. But of course, with very large scale data sets, they have a big disadvantage, which is like the search space for all the like data points, is very big. The project that I'm going to present is actually a project, a new method that we have developed for actually pre-processing and for algorithmic fairness in pre-processing. The second type of methods, and of course, these methods can be all applied one after the next. They are not exclusive, from each other, are in-processing methods. And in processing methods, the objective is to add fairness constraints to the optimization algorithms to penalize discrimination. So the model itself has a term which could be like a regularizer for fairness. Or you could have even an adversarial approach where you are having an adversarial training to debias the model that you might be building. One of the advantages is that you are, at the same time as you're learning the model, you are satisfying the fairness constraints, but of course this is very model and very problem specific, so it doesn't generalize very well. This is just an example of how you would do it. You have your standard optimization problem, you have your standard regularizer, but then you would add another regularizer that captures some concept of fairness. And then, of course, you have the post-processing methods. And in these methods, what you do is you change your decision boundary. Even if you have a biased data and a biased model, you don't have to do whatever the model is telling you to do. So you actually modify the decision thresholds so the outputs will be actually be fair and they will be satisfying, some fairness constraints. And very popular ones are the ones about calibration or tuning the thresholds to make sure that the decisions are not very biased. They have the advantage that you don't need to retrain any model or anything. You have the model as it is, but they are not very efficient. And sometimes they're very based on heuristics. So at ELLIS Alicante, we are working on pre-processing and in-processing methods. And the project that I wanted to present to you is a project on pre-processing methods using Shapley values that we call FairShap. So the main question that we want to answer with this project is what data points in the training data might be causing some unfairness in the model, and could we somehow reweight all the data, the input data, in a way that the model that we learn from this data will be fairer than if we hadn't reweighted. And in our ideal solution, we would like an approach that is based on pre-processing, so is modifying the input data, is model agnostic, so we can use it for any model, is based on a data valuation approach, is an instance level method as opposed to a group level. This means that we evaluate every single data point. We don't evaluate groups of data points, and it's interpretable because we would like to use this in the practical world, in a practical situation. We want to make sure that it's easy to understand. Satisfying all these conditions, we realized that the Shapley values have a lot of the attributes that we need, and that's why we have proposed this method called FairShap. So taking inspiration from the Shapley values, so the Shapley values is a well-known method from, I guess, game theory, and there is the concept of determining the Shapley values of a data set, which basically measures the contribution of each data point to the accuracy of the model. And what we are interested in is, instead of measuring the contribution to the accuracy of the model, measuring the contribution to the fairness of the model. Generally speaking, how it works is you have a value function, which in our case, it will be some fairness metric, and you compute the value on the data set with the point of interest minus the value without the point, normalized by all the possible subsets of points, and you do that for every single point, and that way you compute the Shapley values for that data set. In our case, I'll skip this slide. In our case, what we want to do, as I said, is having a value function that, instead of measuring the accuracy, is measuring the fairness. But we have a big problem, which is that the original definition of the Shapley values of a data set is extremely inefficient, computationally speaking. It has 2n times the model complexity times 2 complexity, and it's also model dependent, because to evaluate, to determine the value this value function for each data point, you actually have to have a model. So given that this is not satisfying our constraint, because we wanted to have a model independent approach, a model agnostic approach, we have based our method on an efficient implementation of the Shapley values that is actually a lot more efficient computationally, and that it doesn't depend on any model, it's model agnostic, because it's based on computing distances between all the different data points, either in the input space or on some manifold. So using this efficient interpretation, we basically have developed an extension, so to say, or we have based ourselves into this interpretation to adapt it to algorithmic fairness and to use algorithmic fairness functions to determine the value of the data points as opposed to accuracy or some sort of like standard performance function. In such a way that like any other data evaluation approach, it has two steps. In the first step is computing the weights on the data. And once you have the weights, then you use this weighted data set to train your model. As you see on the step one, on the weight computation, we don't have any model. So it's completely model agnostic. And what it does is it computes the fair Shapley values, so the contribution to each data point in the input data set to the fairness of the overall model. Based on that, every data point is weighted, and then the model is trained with these weighted data points. And the objective, obviously, is that the resulting model would be a lot more fair than the model if you didn't reweigh all the data. To see it visually, so this is an example with real data on face recognition, where we have popular face data set is the LFWA data set, and it's a data set that is biased in terms of gender. So we have a lot of more male than female examples. So if we were going to train a model and use it, there would be a bias in the model, especially if we want to test the model on other data sets that are, more fair, like the fair faces data set. So a model trained on LFWA and tested on fair faces performs very poorly. So what we want to do is to see how we can leverage a fair data set that will help us move the decision boundary from the red line to the green line, which is a more fair decision boundary than the red line, because it's a lot more inclusive of the blue data points than the other one. So to do that, we compute the fair Shapley values of the data points, and what we find is that the points that are around the decision boundary for the minority class, in this case would be the class 0, have positive Shapley values or fair Shapley values, and then the points that are around the decision boundary but belong to the majority class, they have negative values. So when they are weighted, they are able to shape the decision boundary. We actually, some of the experiments that we've done are actually on face, on these data sets for faces. And here what the table shows is training and testing on the fair faces data set, which is a data set that is fair, so is balanced in terms of the gender and the races of the different individuals, and training with different types of data sets. So if we train and test with fair face, we get this is sort of like the gold standard. We will get high accuracy and very good fairness metrics, like the accuracy disparity or the equal opportunity. The lower the accuracy disparity, the more fair the algorithm is, and the higher the equal opportunity, the more fair it is. If we train the system with biased data sets like LFWA or CelebA, we don't get as good performance, but more importantly, the systems are extremely biased, generally benefiting the majority class and damaging, having a negative impact on the minority class. So using our approach, we are able to maintain a similar level of performance because we are using the same training on the same biased data sets, but reweighting these biased data sets. And what we can do is maintain a high level of accuracy while at the same time having a very significant improvement on the fairness of the models. And visually, what we see is that these are the weights assigned to the different data sets, and we see how the the majority class gets different weights than the minority class to try to shift the decision boundary. We've also done a lot of experiments with data sets that are generally used for algorithmic fairness, like the Compass data set or the German credit data set or the adult data set. And what we have obtained with our method is very similar level of performance that state-of-the-art models, but with orders of magnitude larger fairness, a lot more fair models than you know, using other simple reweighting approaches or not doing any reweighting. And we are talking about, you know, orders of magnitude of like more fair systems. So it seems that this approach is definitely very promising to as a pre-processing approach to achieve algorithmic fairness in a model agnostic way, using any model as your main machine learning model to perform whatever task you want to do. So this is ongoing work in both cases. So it's sort of like there's a lot more work that we can do, but I wanted to share with you some of our preliminary results. So just to conclude, my talk today has focused on biases, and basically biases are everywhere. We humans have tens of cognitive biases, and we think that AI systems could help us make better decisions if they are aware and they know about our own biases. But also, of course, algorithms are biased, and we need to explicitly model fairness in the machine learning process to make sure that, you know, we don't have bias in the algorithms. These are some of the relevant publications only on these topics, on the topic of algorithmic fairness and sort of like ethics and biases. And with this, I just thank you for attending my presentation. Thank you.
Great. Thank you very much for this very, very nice talk. So we still have time for a few questions. So, and I see there was a hand before, and I'm sure there's also a few people who have questions. So just go ahead. Xenia, did you have a question?
No, sorry, I didn't.
Oh, sorry. I just saw a hand and thought you.
I think they were clapping digitally.
Yeah, it was a clapping.
Yeah. All right. So does anyone else have a question? I mean, on this part, but of course also on the first one that we already had a few discussion items, but still, of course, both. There are no questions.
Well, we already talked a bunch before, so
Yeah. So then
case,
maybe I have one, maybe also to hopefully break the ice a bit. So I was wondering, like, where do you see bigger potential? Is it that we fix if we fix the data that this would be effective to address biases and you know, negative effects of current models, or is it the methods, or does it really have to be a combination of data and methods that need to be improved? Where do you see the bigger potential, so to say?
I mean, so that's a very good question. I mean, they are not exclusive from each other. So obviously, you can, you know, do everything, pre-processing, in processing, post-processing, you know, at all stages. As I explained in my presentation, the reason why we there's something that I didn't mention because I went really fast, but I think maybe it's relevant now. So the reason why we're very interested in pre-processing methods is because they're model agnostic. So we're really interested in seeing how much you can fix the data. So, you know, it doesn't matter which model you use later. You have some guarantees that it will be a more fair model than if you didn't. But also, and this is actually quite interesting, and this is what we did on the faces experiment, in some scenarios. So as the community and as society is becoming a lot more aware of the existence of algorithmic biases, there is a lot more effort in trying to create unbiased data sets. in trying to create demographically representative data sets. For example, the Fair Faces dataset is an example of a faces dataset that has been created on purpose to be balanced across, different sensitive attributes. The problem is these fair datasets, that would be the ideal datasets to train unbiased models. There are very few of them, and they are also not very large scale. So to train a very large language model or to train a huge, neural network, you need massive amounts of data, and that data is probably very biased because it's data coming from in the wild, from society, which is probably going to be biased. But what we did on the FACES project was use the FAIR data set, which is a small data set, to learn the weights that then we use to train a big model on a very biased data set. And that actually helped the model be a lot more unbiased. So there is also this interesting idea of how do you leverage a small yet fair data sets to be able to learn something from that will enable you to learn unbiased models, even if you are training them with large data sets that are biased. Having said this, of course, the in-processing methods, we are also working on in-processing methods. I didn't have time to explain those projects. And we are particularly very interested, and this is the area that we're working on. We are working on in-processing algorithmic fairness in graphs. There is a lot of social problems that you can represent as a graph. We humans are connected, to other humans. So there is an entire genre of problems that involve solving, building models that learn on graphs. And of course, graph neural networks have a lot of issues with fairness, as well. So we have been working for the past year on graph rewiring, and we gave a tutorial actually in the Learning on Graphs conference on graph rewiring. We have a paper on graph rewiring, and we are building all the theoretical sort of like a framework to be able to do fair graph rewiring and to be able to learn fair models on graphs, and that's an in-processing approach. So that involves adding fairness concepts in the learning itself. So we are working on both the in-processing and the pre-processing, but I think the pre-processing is very powerful because we have so many data sets out there that are very biased, and I think if we have a mechanism to reweight all these data sets, so there is some guarantees that the models that are trained on the reweighted version of the data sets will be less biased. I think that will be tremendously helpful.
Yeah, and do you know, is there research on trying to quantify like where the bigger potential is, kind of attacking this bias problem from at these different levels?
Well, I think it's very. I think one of the hardest parts is that the data, the pre-processing methods are so data dependent that I think a lot of it depends on the nature of the data, the amount of data, the types of like biases that there are in the data. So I think that's one of the challenges. There is actually, I don't know of any, there aren't really a lot of proofs of pre-processing methods where you could theoretically demonstrate that the model that you learn is 100% always going to be less biased, and how much, because it depends a lot on, because if it is model agnostic, of course, depends on the type of model that you will learn, but also depends a lot on the data. So that's definitely an open research area. Try to have a more formal demonstrations of fairness guarantees in the pre-processing approaches. When we use the Shapley values actually satisfy some axioms that are very relevant for fairness. So it's not, there is a lot more reasons why we chose the Shapley values as our inspiration for FairShap. And some of them are related to having these axioms that provide some kind of guarantees in terms of the behavior of the values that we are attributing to each data point.
Okay. Right, thanks. There was also a question in the chat, but it seems like that this one got answered in one go.
Okay, I didn't see it. Sorry.
Yeah, I can. No, it's fine. It was while you were talking. It was coming up. It was also about fairness guarantees. I mean, I can read it. Maybe you can just add to this. So, so Louis asked this question. I was wondering about what kind of fairness guarantees can be given out of sample for this reweighting scheme. In terms of generalization, especially for these big models that interpolate the data, so that the weights lose importance with time. This is an issue with unbalanced data sets. But I'm not sure if you've observed something similar in these fairness applications.
I didn't. Maybe I can read the chat.
Yeah, you can just click on the top bottom
I do
right.
stop
There's
here.
this small bubble that you can just click on.
Oh, here, yeah.
So it's a bit of a longer.
In terms of generalization that interpolate data, so the weights lose importance over time. Yeah, so out of sample for this reweighting scheme. Yeah, so that's yeah, so we haven't done a lot of experiments along that line. We in the fairness literature, there are a lot of like benchmark data sets, like the tabular benchmark data sets is the ones that I presented. Like there's a bunch of them, but they are all relatively small compared to state-of-the-art large models. So I don't know. We haven't done any experiments with out of sample sort of like data, or my mic is not working. Yeah, so as I said, for the pre-processing methods, there is still a lot of open questions in terms of theoretical guarantees. And actually, if Luis is interested on this, we'll be more than happy to collaborate with him on that. Because we, as I mentioned, we decided to inspire ourselves on the Shapley values because they do have a fair amount of theoretical guarantees. It's an old concept, from game theory, is very well studied. But as far as we know, no one has use this idea for fairness. So yeah, so send me an email, Luis, and we can have a discussion, because that could be a very interesting collaboration, actually.
Great. Yeah, he added.
Awesome.
There.
Yeah.
Okay.
Right. So yeah, my email it was on the slide, and it's nuria@ellis-alicante.org. Yeah, I'll type it
Yeah,
here.
we can also share it and send it around, Louis, afterwards if you can't find it. Just let me know.
Yeah.
Maybe one other, it's not only a question, it's also maybe a suggestion, because you mentioned the lack of data sets, of unbiased data sets. And I was wondering, I mean, wouldn't that be a perfect, task for a network like ELLIS to say we do a data collection like Europe-wide, essentially, on core computational tasks, and then these data sets are provided to the community, all across Europe and also beyond. Because it's a huge effort, of course. So a single lab couldn't do it. But if a network like ELLIS would kind of join forces, so to say, wouldn't that be something that ELLIS could, kind of put forward as one of its goals or tasks to contribute?
Yeah, I mean, I think that's a good idea. I think it makes a lot of sense. In fact, I was a little bit related to this, but maybe not fully. But the European Commission, I don't know if you're kind of like following all the European Commission initiatives that are going on, but so there is a number of acts that are being approved, being the AI Act one of them, but there are other acts, and one of them is the Digital Platforms Act, which is to regulate social networks, basically, and data platforms. And I think one of the ideas that they have is to force, I guess, or to make it possible for researchers to use the data from data platforms for research purposes only. And when I talked to the European Commission about this today, and I told them, well, this seems like it could be an interesting initiative also for ELLIS, because they want to have a better understanding of what the community needs, and so forth. And it's a little bit related to what we're talking about the data, right? Because the data is biased. Most of the data is biased, but then there's also the other big challenge, which is a lot of the data is proprietary. And it's not freely accessible. And someone asked me earlier about the phases and where we were getting the phases for the attractiveness halo effect project. And, we are not scraping faces from social media, obviously, because that's completely illegal,
Yeah.
unethical. But, without data, it's very difficult to do any data-driven machine learning, obviously. So both ideas, I think, are a little bit related, and I think
Yeah.
they're very relevant for ELLIS. I mean, I guess we don't, so the widest initiatives, I guess, that we have in ELLIS are the ELLIS PhD program, because it involves a lot of most of the fellows and so forth. And then we have the ELLIS research programs. In the ELLIS research programs, I'm actually co-director of the research program on human-centric machine learning, and algorithmic fairness is one of the topics of this program. This could be relevant maybe for the something that maybe the program could try to promote, even if it involves, the broader community beyond, the program people, or is, I don't know, or if there is anyone in the call that is passionate about this. I mean, basically, I think ELLIS is very open to initiatives, but there is also limited bandwidth in the sort of like individuals that are in the kind of like the board of ELLIS and so forth. But I think it's very supportive if people want to take ownership of different ideas, and try to push them forward. I think that's a very nice idea. I like your idea. So
Yeah.
maybe
Yeah, I'm thinking
something to
also,
propose. Yeah.
which tasks to work on. I would imagine that the communities could propose tasks. So there could be a process where individuals or groups could propose, let's collect a data set for, I don't know, person identification or, counting. And then, if accepted, then this could be kind of distributed within the network. And then, labs interested in that could contribute data. Maybe there could be a protocol of what type of data, which conditions, which setting, and so on. I mean, of course, this requires some work, but I could imagine this could be quite nice.
Yeah, it
People
could
all
definitely
across
be
Europe.
very helpful. Yeah. And I think it's become a clear issue with all the generative models, be it for text or for images, because the data in the wild, we know that is going to be very biased because society is biased, and also because the digital representation of society is even more biased than society itself, because at the end you need a digital representation of that society to train, to get the data. So maybe you can think a little bit about it, and maybe you can send us a message to the ELLIS board, or try to figure out, how to do something like this. But it could certainly be very interesting. And I'm pretty sure the European Commission will be very supportive of something like this, because they are thinking along these lines with this act, for digital platforms, for example, and trying to give access to researchers, because they know that Europe has a disadvantage because all these companies are American or Chinese, and then there is this disadvantage that there is no big technology companies from Europe, right? And then so the European scientists don't have, there's no access to a lot of the valuable data. Yeah.
Yeah. All right. We still have time for maybe one question or two quick ones. Not sure many people seem to had to leave already, but maybe if there still is a question, then we could certainly still answer this one.
Yeah, otherwise you can just email me later, or of course you're all very welcome to come to Alicante. As I said, we're having a lovely weather right now, really nice. And also the lab is very nice. We're very small, but we are very energetic, and we do a lot of things.
Okay. Yeah, cool. No, I might actually take you up on that offer.
Of course, especially when it's like ugly in Stuttgart,
Like today and yesterday, yes.
Oh, here it was like beautiful day today. So
okay.
beautiful. Yeah, 24, 25, sunny, really pleasant,
Nice.
breezy with a breeze from the sea. Yeah, really nice.
Sounds good. Yeah, it seems like there are no other questions. I mean, we're actually doing quite well in terms of time, because we had this, 90-minute slot, and turns out we
Okay, perfect. Yeah, I have a
nearly
meeting
there.
now
So,
also. So,
Nuria, thank you very, very much again for this super
you're
interesting talk and
welcome.
also the discussion. And I'm sure that some people will reach out post-talk, I could well imagine,
Cool.
to connect. Otherwise, yeah, I hope we see each other soon at some
Yes.
ELLIS event or elsewhere. And to everyone else, thanks a lot for coming, and also for being here and listening. And yeah, have a nice
Thank
day, I
you.
guess, and see you soon.
Thank you. Yeah, thank you very much.
Thank
Ciao,
you very much
ciao.
again. Thank you.
Ciao.
Bye-bye.
Bye.